Hey everybody, this is welcome to Newton 3 and interacting objects. Alright, so we've kind of ignored Newton 3 for a while and just it's been like, yes, it exists, but we're only going to use Newton 2. The main reason as to why is because we've only been dealing with a force acting on a single object. To really understand Newton 3, you need to see how it behaves with other objects. All right, so yeah, what's what does Newton 3 state? All right, Newton 3. Whenever an object A exerts a force on object B, come on, object B exerts a force that is equal in magnitude and opposite in direction. So, all right. Two important things about this law. Important things. It always involves two objects. All right. Another thing. Each force in an action reaction each force in action reaction pair acts on different objects. All right, so if I have my object A right here, it emits a force on object B, then object B emits a force on object A. All right, so you see object A is acting on object B, and object B is acting on object A. So that's what this note is trying to explain. All right, and of course the forces must be equal in magnitude and point in opposite directions. All right, so yeah, exactly. So we will begin analyzing Newton 3 by looking at objects in contact. All right, that's one. So by object in contact, I mean objects that are basically touching each other. So if I have, oh my God, okay, if I have a square like this, it's touching another mass, another square. All right, so they're in contact with each other. So yeah, now it's important to note. Okay, important to note when two objects are in contact, all right, they will move at the same acceleration. All right, when two objects are in contact, they will move at the same acceleration. So if I have an object A right here, an object B, and I have a pushing force, like somebody's pushing it. Oh my god. Okay. I don't know what I've just drawn. I'm sorry. Someone is pushing it. Let's say this is a hand. Yeah. Somebody's pushing it. Yeah. I have my free body diagram. I'm gonna have the force push, the force of push, F push. Really, it's only going to be on A, which we'll see later. And so this is the free body diagram of the box A. I have the force of B on A, because B is also exerting a force on A as we push it. I also have my normal force, and I also got my weight force. Yeah. So now, so this is the free body diagram of A. Then if I have my free body diagram of B, I have the normal force, weight as well. We'll only have the force of A on B. All right, so despite them having two different forces on each other, they will both have the same acceleration. Did you see why is that? You see, if we look at the forces, the F of B on A and F of A on B will cancel out. Then our net force is going to be that actually making them move around is going to be the F push on A. So that net force has an acceleration, and that's the acceleration they're going to share. So yeah, let's see it by a problem. Yeah. Let's look at an example. All right. A 5 kg block A is being pushed with a 3 Newton force. In front of this block is block B. If the two blocks move together, what force does block A exert on block B? All right. So if we're not giving so I'm kind of going to redo our steps to solve problems in Newton 2. If we're not given the drawing, we have to try to draw it ourselves. All right. So like here I got a 5 kg block and a 10 kg block, and I know they're in contact. So this is how I would draw them. All right. And yeah, if the blocks move together, what force would block A exert on B? So a key thing to highlight is what we're looking for. All right. So you want to know what force does block A exert on block B? Okay. So our step one, like I told you, draw it, because we don't know what it looks like. So this person is the person pushing block A, 3 Newton force, and block B is in front of block A, and that's the scenario. All right, free body diagrams. When two objects are in contact, draw separate free body diagrams. Always, guys, always. All right, when two objects are in contact, draw separate free body diagrams. All right, and on the free body diagram, you should always or never include a force that an object exerts. All right? If I'm the force exerting the object, I don't include the force I'm exerting. I only include the force I'm experiencing. All right? So like in the third law force, I have two particles. Yeah? And so let's say I know F of A exerts a force on B. But in my free body diagram, I'm only going to include for A, so this is a free body diagram for A. I'm only going to include the force of B on A. I won't include the force that A exerts on B. That's a wrong way of doing a free body diagram, and you get your math wrong if you do that. Okay, let's solve it systematically. So step one, like I said, drawing. All right, I drew the problem. I can see what's going on. Now, free body diagram. Remember, they have to be separate. So let me see if I can change the color. What's a good color to have? Okay. Block A. Let's begin with block A. So of course we have our normal force on the surface. So we have our weight. Yeah. Normal weight. Yeah. And what do we have across? We have the force of the push. And then we also have the force of B on A. All right? So this is what my free body diagram is of A. Free body diagram of block A. This is how it should look. Okay? I know that the push is going on block A. Block A feels the push. But, so block B on A, block B, so when block A feels the push, block B acts on A. All right? So notice I haven't put the force that A acts on B. All right? So that one goes on the free body diagram of block B. So, okay, I got my weight, I got my normal force. I got my F push, and I got my, oh, no, sorry, apologies. We don't feel, F of B doesn't experience F push. And neither does it experience anything there. F of B only experiences F of A on B. All right? That's the free body diagram for block B. F of A on B. So, in our analysis, say when we get the sum of forces in each direction, yeah, what we should do is do it separately again for each free body diagram. All right. So if I have block A over here, I look at my forces in the X direction and Y direction. So yeah. So forces in the X direction, what do I have? I have F push. In the X direction, I have F push for A, F push. And then what else do I have? I got, in the negative direction, I have F of B on A. Yeah. What about the Y direction? What do I have in the Y direction? Well, I know I got my normal force, I got my weight. So once I change these, I put in them, I know in the Y direction I'm not moving at all, so that's 0. So my normal force is gonna equal, if I take the weight the other side, gonna equal my weight. All right, I know that for sure. So that's block A. But so now, are we accelerating in the direction of x? Yes, we are. So what we do in that case now, we plug in ma for f of x. Ma is gonna be equal to f push minus f. This is in the x direction. Max f of b on a. All right. So I'm just gonna put that down there. Yeah, because I can just have room for block B. So I'm gonna leave that like that for now. Yeah. So now we analyze block A. Let's analyze block B. So block B. Fx direction. By the way, so yeah. Then f of y direction. All right. So in the y direction, we have our normal and our same thing really. 0. In the x direction, we only have f of a on b. Like that's the only force we experience. Okay? Not just the question. Even the question had friction, we can probably put friction, but we only have f of a on b. And remember, just to iterate the previous principle, we can only have the forces that are exerted on us, not forces that we exert. F of b is exerting object B is exerting a force on object A, and that's on A's forces, but not on B's sum of forces. All right. So I have my equations now. So I don't think I'll need any information from the y direction. I can just compare my equations in the x direction. All right. I know I'm accelerating. So hold on. I have MAY is gonna be equal to f of a on b. All right. So now let me compare my equations. Yeah. So I got max is equal to, and this is mass A. Just to be clear with you guys, that's mass A and mass B. Yeah, the box mass A. Then we got mass B is equal to, let's see. Oh, I'm only comparing the x direction. Yes. So MA B is equal to f of A on B. MAX is equal to F push minus F B on A. All right. So this step here is titled Apply Newton 3 Conditions and Newton 2. So we applied Newton 2 already. We've said MAX is equal to MB. So now what to do here? The principles we know. AX, so AX, and so the acceleration is the same. All right, acceleration is the same. And if I was to write this properly, I'd say AX and ABX to symbolize block A's acceleration and block B's acceleration. So I would have AX is equal to ABX. It's going to be equal to just a single A. All right. So that's a characteristic of interacting objects. Acceleration is the same. What other thing can I do? I know Newton 3. I know Newton 3 tells me that my F of A on B, which is what we want to find out. Remember what our question says? I want to find out the force that block A exerts on B. I want to find out the force that block A exerts on block B. Like right there, right here. What does the force of this block A exert on block B? So I know that f of B is equal to f of A on B is equal to B F on A. So I can substitute this in my other equation. So now my new equations, after applying the conditions, will be ma acceleration, F push minus F of A on B. Because Newton 3 allows me to make that substitution. And then here I have F of B, MB is F of A on B. So mathematically, this is correct. It's correct mathematically because I've just done what Isaac Newton said I could do. I've substituted F of B on A, and I've called it F of A on B. And this is because I have Newton's laws. And Newton 3 tells me that F of A on B is equal to F of B on A. So I can now simply solve for F of A on B, what I want, by combining the two equations. So first I can get the value of A from this equation. So let's say I have A is equal to, if I solve for A here, MB, A is going to be equal to the force of A on B divided by MB. Then now I can plug in this A into that equation. So I have MA is going to be equal to F of A on B divided by MB is equal to F push minus F of A on B. All right, now this is just an algebra problem, all right? Like a common phrase that I say, the physics is nearly done. We want an expression that would just tell me what F of A on B is. So let me try and get the F of A on B on one side and F push and other stuff on the other side. So now, let's see. To get rid of this, of the MA and AB, I multiply both sides by MB over MA. I get this MB over MA. So here, they'll cancel here. And then I'm going to have the force of A on B is going to be equal to F push. For the sake of just clarity, I'm going to just I'm just going to write it in this sense. F of B, A minus F of A on B. This is going to be it's B over A, right? My mistake. It's going to be B over A, B over A. All right, so I'm getting somewhere. I can now then take this guy, I can take it across the equal sign, have F of A on B minus F of A on B. It's going to be equal to F push multiplied by F of B by MB over MA. And then over here, I forgot my MB over MA. That becomes plus, because I'm going to cross the equal sign. So I can factor my F of A on B out. F of A on B, that becomes 1 plus MB over MA Yeah, it's going to be equal to F push times MB over MA. So I can divide mass A and mass B. Then I cancel this out. The force of A on B, which is the force of block A on block B, can be determined by. I know most of you who are math enthusiasts are probably not too happy about my mathematics here, but it works. So I'm sorry, but this is what I'm going to do. Okay, so now we have a formula. And boom, the physics is done. We have our expression. So now we can just plug in. We know MA is equal to what? What's MA equal to from the previous question? It's 5 kgs. MA is 5 kgs. MB is 10 kgs. And what's F push? F push is 3 newtons. So we can just plug in this into our equation over here. If you want, you can simplify it. If you really don't like how I've done this, you can simplify it. But if you plug it like this into a calculator, you'll get your answer. And yeah, that's how we'd handle Newton 3 problems. I hope this was helpful. And yeah, I hope it was a fun video for you. Awesome. All right. See you guys in class.